Hello, my name is Eric Bernstein, and I'm going to be going over some reviews for the Honors Algebra 2 Unit 1, Topic 1 through 3. This is going to be a 3, possibly 4-part series relating to the formatives that are given that are hopefully in relationship to kind of like a review for the progress check that is going to be this specific quarter. So what I plan on doing is I plan on going through each individual problem and working out the step-by-step process and what are kind of like the expectations. I'm not going to be filling out all the answers completely to the fullest extent, but what I plan on doing is giving you a little bit of an overview on how to kind of set this up and to kind of move forward. So we're going to start off with Unit 1, Topic 1. So it says, using verbal descriptions below, write an original function and its inverse, explain your solution strategy. So what I'm going to do is I'm going to start off with a number. I'm going to call that n, and I'm going to add 1 to that. Then the second step is it says take the square root of that quantity. So what I'm going to do is I'm going to place the square root over the whole quantity, and then I am going to subtract 3. So this is going to be our first function. And since I'm using n as my independent variable, I'm going to say f of, so it's going to be f of n is equal to square root of n plus 1 minus 3. Now, when I'm going to actually be creating its inverse, so this is considered to be our original, when I'm creating my inverse, I actually have to do these steps backwards. But this time what I'll do is I will actually be using a different variable just to kind of help differentiate the difference between the original one and the inverse one. So instead of actually subtracting 2, I'm going to take a variable, I'm going to say x, and I'm going to add 3. So instead of subtracting 3, I'm going to add 3. Then it says take the square root of that quantity. Well, the opposite of square root is actually something that is squared. And then don't worry about with the starting number because I actually started with a number, so I'm adding 1. But then instead of adding 1, I'm going to actually subtract 1. And I'm going to say that this is going to be equal, I don't want to use f again, so I'm going to use g of x. So that is in a sense my process. So these two equations are inverses. Now, moving on to step number 2. What ends up happening here is Jameson inputs the number 39 into the function machine below. What's the result of the final output? Well, what ends up happening is if the 39 gets placed into, let's say, our f of n, right? So in this case, this is going to be f of 39. And then we get whatever the value that might be. In this case, it's actually probably not going to work out too great. So we end up getting, let's say, f of 39. And then we place this value into the inverse function. So that's going to be g of f of 39. And what actually ends up happening is if these two functions, both the g and the f, are inverses, they will actually cancel each other out and you're left with just 39 as the final result. So I can actually write g of x as the same exact thing as saying f to the negative 1 of n, right? So this really means saying that that is our inverse. So if we do the inverse of the function of n, we can almost kind of see that this inverse and this function, they actually cancel out, and I'm left with the final result as being just n, or in this case, the 39 is our answer. Moving to number 3, determine the inverse relation for each function. Explain how you determine your answer. So the first thing I'm going to do with these specific types of questions, more specifically A and B, my plan is to write them in terms of my y is equal to negative 4/5 x plus 7. And to find the inverse rather quickly is to flip the variables and then solve for that specific variable. So you can talk about this as kind of undoing those processes to get to our inverse, so to speak. So what I'm going to do is I'm going to say x equals negative 4/5 y plus 7. And then what I'm going to do is I'm just going to solve for y. So in this case, I'm going to subtract 7 to both sides. So I end up getting x minus 7 is equal to negative 4/5 y. And then to undo this negative 4/5, I'm going to multiply by the reciprocal, which is 5/4. right, negative 5/4. But you'll also notice right over here is if I end up multiplying the other side by negative 5/4, I'm not just doing it to the x or the -7, but I'm also doing it to both of them. So I need to make sure that that's in a quantity. So those two cancel. So I'm ultimately left with y equals negative 5/4, and then we'll have x minus 7 on the outside. And so this is going to be what we call our inverse function. So I'm going to change the y back to be something a little bit more kind of catered towards what the original function is. So this is saying f to the -1, which also really means that this is the inverse function, and that's going to be equal to negative 5/4 parentheses x minus 7. And that's my inverse function. Depending on your specific teacher, some will actually let you keep it like that, but it's a good idea since if we are trying to find our inverse, that is how you actually, that's the correct notation for an inverse function. Okay, next, same deal. Y is equal to 2x to the third minus 13. So I'm going to switch the variables. X is equal to 2y to the third minus 13. I'm going to move the 13 over. X plus 13 is equal to 2y to the third. Divide both sides by 2. Now remember, you have to divide everything on the left-hand side by 2, not just the x, not just the 13, but both of it. So then I get x plus 13 divided by 2 is equal to y to the third. Now, at this point, I'm trying to get y by itself, so to get rid of that cube, I have to do a cube root. But not just to the numerator, but actually to the whole thing. So I actually have to do the cube root to not just the x plus 13, but also the 2 as well. So I'm left with y equals cube root of x plus 13 divided by 2. Now, some of you guys might be thinking, you've seen your teachers do some type of maybe like a square root to both sides, and they'll put a plus or minus. That is only applied to roots that are tied with an even number. So in this case, since it is a cube root, we do not need to worry about a plus and minus version. It's only if you have something that looks like this, an x squared is equal to 9, right, and you do a square root to both sides, you need to account for both versions. But since this is a cube root, you do not need to worry about that type of case. Okay, moving on from there. So we have a set of ordered pairs. This is fairly simple since to figure out the inverse, what we did was we switched the x and the y values. So really the inverse of all these ordered pairs are just going to be the flip versions of these. So 5, negative 13, negative 9, negative 9, negative 2, negative 5, negative 5, negative 1, and so on and so forth. Right, pretty straightforward. Just flip the x's and the y values. Now, it says for number 4, it says the points A and B, the point AB is on a graph of F. So what are the coordinates of the corresponding point that is on the graph of the inverse of F? So what ends up happening here is if I end up having, let's say, a graph, and I have the point, let's say, AB, A comma B. Right, here's my point. And I'm trying to figure out, in a sense, where is that other value that is going to be at its inverse? Well, I do know that if I end up having a line, that is the y equals x line, what ends up happening is that the point is actually going to be located directly across from it. It's actually going to be a reflection on it on the opposite side and the same distance away from that point. That is actually going to lead us to the point right here, and this point is kind of almost like intuitive with saying that if we've been switching the x and y values for so long, we're actually just still switching the x and y values. So this is going to be our B coordinate A, because we're switching yet again the x and y's. And just to kind of confirm that, right, this is also going to be the same distance away from either side from this y equals x line, because it's in a sense a reflection. And you can also test to see if that midpoint is also going to be on that line as well. But yet again, there's multiple ways of kind of justifying your answer when it comes to this problem. I just kind of gave you a couple of them. Moving right along, so it says graph the inverse relation for each given function on a separate coordinate plane explain your process. Okay, so my favorite thing with these is actually I like to start to draw it on the actual graph itself and then work from there. So the thing I like to start off with first is I like to start off with that x equals y line. So kind of like how I worked with the other problem. Now you'll notice right here, it intersected the y equals x line. And also something to keep in mind that if it intersects it at that specific point, it's also going to intersect the inverse. So, and it's also going to be a mirror reflection of that. So the next thing I'm going to do is I'm going to get a couple points that I can see. So this is the point, let's say -3, -1. This is going to be the point -2, 0, and then this is going to be the point -1, 1. And what I'm going to do here is I'm now going to, in a sense, flip these. So I'm going to say -1, -3, so -1, -1, -3 is actually going to be right here, which kind of corresponds with that. And you can kind of see the distance is still the same distance away from the y equals x line. I'm going to say -2, 0 is going to be 0, -2. So that's going to be right there. And then the last one's going to be -1. It's going to be -1, 1, so it's going to be 1, -1. Now, how's this graph going to look? Is it going to look something like this, right? Because that's the other graph. But we can actually almost see that that looks more like a translation than an actual reflection over that y equals x line. So that's actually not our graph. But I do know that it does intersect this point as well. So if this is kind of coming down at the bottom right here, it's going to be coming from the left over here. So we end up getting something that looks like this. And I think I might want to redraw that. Something that looks like that. And if you notice right here, notice how it's getting closer and closer to the y-axis. For the inverse, it's going to be getting closer and closer to the x-axis. So, and then you can visually see that this is actually going to be a reflection over that y equals x line. So to just rewrite it, so those 2 points, and I'm going to just kind of roughly kind of sketch where that's going to be right there. And so this is going to be my line, just like that. Okay, moving on to the next one. This one's fairly easy. More specifically, since this is a linear equation, I can just grab a couple points. So this is going to be 0, 4, so I'm going to do 4, 0. I'm going to do 1, 2, so that's going to be 2, 1. And the last one is going to be 2, 0, so that's going to be 0, 2. And then it is going to be this line, like this, just like that. There we go. All right. So it says Manuel notices that his electric bill reflects a monthly fee of $20.57, as well as a charge of 0.0868 per kilowatt hours of electricity used. Write a function that will help Manuel determine the monthly cost for his electric bill. So what I'm going to do here is I'll set up just kind of a basic equation. So we know that the monthly fee is some type of standard fee that's not really going to change in value as the month kind of progresses. It is just that flat fee. So I'm going to put that on the very end. So I'm going to put that as 20.57. And then I'm going to add, in a sense, what is going to be the charge per kilowatt hour. Now, kilowatt hours means that how much electricity are you using. So depending on how much electricity, so I might say maybe the total cost, I'll say the total of the bill is going to be, so I'll say 0.0868, and I'll choose a variable for this. I'll say K for, in a sense, kilowatt hours. By the way, so I'll just also say T is going to be my total cost, so that I have my variables kind of organized, and then K is going to stand for the kilowatt hours. So the kilowatt hours. Okay, so there's my function that relates the whole electric bill. So it says, Manuel lost his October bill, but knows how much he paid for the month. So it says, write a function that helps Manuel determine the amount of electricity used based on the total cost of his bill. Explain your solution. So I'm now writing a function in terms of k, so which means I'm actually solving for k. So how I'm going to organize this is I'm going to, in a sense, start with this original equation, so t is equal to 0.0868 k plus 20.57. So if I'm solving for k, I'm going to move the 20.57 over, so t minus 20.57 equals 0.00, nope, only one zero, 868k. And then divide both sides by 0.0868. 0.0868. And then, so I'm left with the equation k is equal to, so this will give us the number of kilowatt hours he actually ended up spending on his actual bill, which will end up giving us t minus 20.57 over 0.0868. Okay, so just determine the amount of electricity used, write a function out. So explain your solution. So right, as soon as he places in the total, we can evaluate it from there and we can get that kilowatt hours. So it says Memo's total October bill was $412.17. How much electricity did he use? So we're just going to take the 412.17 minus 20.57 and then put it all over 0.0868. And so that should give us how many kilowatt hours are left over. So that should end up giving us roughly the kilowatt hours of 4,511.52. And then we're going to say kilowatt hours. Just making sure that we're actually using the correct labels and units for our answer. Okay, it says, how could you use the original function to check your solution? Well, very simple. So what I could do here is actually I could take that original solution, so I'll take t is equal to 0.0868 times, and then in a sense put in that kilowatt hours I got, so 4511.52. So 4,511 and 0.52, and then plus 20.57. Now I'm hoping to get what value? I'm hopefully I'm going to get 412.17 from there, and so I end up getting a total that is going to be equal to, in a sense, that 412.17. So $412.17. Okay, I hope you enjoyed this video. Thank you for watching. Yet again, this will be multiple parts. I'll end up going over formative 1 for topic 2 in just a little bit. Thanks.